I'm going to teach you about real-time spectrum analyzers and give you the 30,000 what the difference between a real-time spectrum analyzer and a swept-tune spectrum analyzer. Arguably today, the 2.4 gigahertz license-free band is the busiest piece of spectrum in the whole world. Everybody is building devices to go in the 2.4 gig band. The rules are, we can't cause interference to anybody else, and we have to deal with any interference that we actually receive. So how do we do that? Well, we employ frequency hopping. We employ clear channel assessment, meaning I listen before I transmit. It's really difficult for us to actually measure these things. A swept-tune spectrum analyzer has been around for a long time. A swept-tune spectrum analyzer, what we see on the left-hand side of the display and what we see on the right-hand side of the display, it's not actually collected at the same time. So if I have a signal that's moving around, how do I characterize it? Real-time spectrum analyzers, on the other hand, continuously capture all of the information up to their maximum real-time span. We don't sweep, meaning I get that time component. I can find out how often something is happening. If I have to employ a technology that involves me bursting on and off, or sharing the spectrum or listening, the real-time spectrum analyzer actually lets me see that to a much greater detail compared to a swept-tune spectrum analyzer. Bottom line, as engineers are building devices to fuel the Internet of Things, Tektronix is providing the solutions to unravel the interference of things.